I'd like to use 3 examples from what I've done in interfaces, I'd call it, between academic setting and practice and industry. One is integrating renewable energy into buildings more feasible than we think it is. Are we using the right optimization tools as interdisciplinary design platforms? And the third one is, how can we make buildings more adaptable? Just a very brief introduction what P+ is about. It's what I would call a research-based practice. We're not a commercial practice by any means. We're very small and we're very niche, I think. But it's really about connecting design ambitions, performance-based design with research on architectural, but also more systems design scales and industrial design scales. But it's including very positive outlooks on different scales. So it reaches really from, say, mobile phones to wind farms, all sorts of stuff. What's very important, I think, in general, is pushing the boundaries between these 3 cycles that you see. And they all have interfaces and they can be very productive. I think they're most productive when they come together, where you have research and advancing knowledge combining with teaching the next generation of critical thinkers and implementing that in practice. And hopefully those people will get connected. So there's a lot of potential for bright ideas. The second is, at least for architecture and systems design, to consider fully the impact of passive systems design, active operation, and I think what's the most promising one, which is the hybrid approach. And then the last one, which has to do with, I think, an understanding of scale coming from a pretty diverse background in architecture and industrial design and so on. We typically think in projects and project delivery. I think we have to think more in product development. So talking about facades and how they function, I don't think we're enough involved. And then the third one is process optimization. So in terms of tools and methods, down to policy, are we doing the right things in the right sequence with the right participation? So 3 mini case studies. The first one is thinking about tools. And this is a project when I was a professor at Syracuse University, New York. I initiated various work streams with mechanical and aerospace engineering, and this is one of the outcomes. Department of Energy funded tool development for an interdisciplinary design platform. So between architectural design and essentially systems engineering. And the idea really is that you have the qualitative view towards buildings, which is typically the architect, and you have a more analytical, systems-driven, quantitative view. And the idea is to bring that together in a design platform that gets us to understanding each other better, but also designing things basically in tandem. So rather than doing it sequentially, design something pretty and then make it perform well, do that at the same time and basically swap these 2 sides. What I've done based on practice in Germany and here in the UK and the USA is revisit design stages, which I think is another thing we really have to do, and simplify it, from German to US to here. It's between 7 and 11 professional working stages. I think we only need 4. One is to assess a project and think individually about that project in particular ways. What is it really about? Define particular performance goals, not broad-brushed meeting standards, but very particular to that program, to the location, to the use. Design accordingly, apply those ambitions, and then I'll talk about monitor and provide data and feedback in a second. But the other is to be very clear what are the design considerations that we're meeting and decide the decisions we're making. Do they have design impact or not? And go always back in a sort of magic cube fashion where every moment can be captured, where you say, when we've defined the ambitions for the external envelope and we've designed it, have we done what we came to do? And that's basically giving us a framework to identify very particular moments in the process and optimize those. But then there's something that we're not doing enough of, or we're not doing it really at all, which is monitor outcomes. We had this discussion earlier, to document and to provide feedback in terms of data or user profiling or things that other disciplines do, and then go all the way back to assess and redefine the criteria that we've used, reevaluate the tools we've used and the methods, and then provide basically a database that helps me to go back and look at that later and understand where things went right and where they went wrong. So in essence, I'll wrap it up with a few slides what the graphic user interface looks like. You can have a custom project setup, which is entirely bespoke to that project. And processes, you have a qualitative and quantitative project input matrix. You then have varying discipline-dependent ways of viewing performance data. Typically what architects look at has to be, frankly, different than what engineers look at, because architects have a hard time understanding certain graphs and certainly understand how do you make design decisions. And then a 2D and 3D modeling design viewer that allows you to look at different representations of an architectural condition in a simulation environment. So we've done this as visiting professors at Nanjing University, coming from the States for about 5-6 years now, teaching interdisciplinary student teams, very much looking at interdependencies between these different areas of investigation, and have groups with, of course, architects and landscape designers, urban planners, structural, electrical, mechanical, aerospace, and other systems design students from various departments. The second one, so in essence, I think we need different educational models to start with. We need more interdisciplinary collaboration amongst student and faculty bodies. And I think we need different tools. We do three things. We develop new ideas, we deploy those new ideas, because if we don't get them out of the lab, they'll not have the impact that we're looking for. And the third one is dissemination of those ideas and the knowledge it creates. The last one is taking some of that theory again into practice or deployment. And this is a building that is what we call a live lab, a living lab. It's an expo building in the first Chinese green building expo park, supported by the Housing Ministry and central government, of course. And what we did there is basically say, can we support the idea, which we like very much, in bringing together, and this is the Expo Park Phase 1, an industry development cluster, which is very much about research and development, with a demonstration zone, which is live buildings where you can do things. And then we said, can we bring academic partners into the mix that can do research in this building? And the idea is really that the building is never finished. So we basically designed a couple of frames into the structure, which has other benefits that if you want, we can go back later. But in essence, it's about plug and play. It's about industry or academic partners taking facade components, for instance, building a prototype, plug them into the facade, test them, modify them, but have a real live setting for this. The same would be true for roof components and mechanical equipment. And so we teamed up with two industrial partners. One is Trina Solar, who are working on the latest in PV cells. I think they're aware of the lack of efficiencies compared to other systems, so they're working quite hard. But what they did is work on a new generation of transparent PV cells. We worked with Healthway, air purification systems, very much about the argument, is the air better or worse on the inside versus the outside? So what we did is design 3 environmental zones. One is a public area, one is an office area, and one is a residential area, so basically an apartment on top of the building, where you could now test these efficiencies against different building standards and regulations. And then we are the only ones in the park that have a weather station and a climate analysis equipment set up that allows us to actually see that in a larger regional context. We use that extensively to work with, again, interdisciplinary student teams that take the building, speculate on the building performance, which we can then actually see how that pans out in the real-time data capture. And they add systems as they see fit to understand if that would make it work better. And now it's been used by 3 research universities, Zhejiang, Nanjing, and Syracuse in New York. For PhD level research, what we're looking at here is this component, which is a solar chimney. So it's a passive/hybrid operation to precondition air, which you can use to draw air out of the building in the summer, or to precondition the air in the winter and draw warmer air into the building. And the latest is that it's used as a case study for the International Energy Agency for NX 68, which is about indoor environmental quality. And therefore, I think makes a good case how it goes from an initial, really more academic exercise into a build example with industry, and then it becomes a research tool for all of them. And I'll close with that, but back to those 3 questions. If you have any answers, then I'll gladly discuss them. Thank you.